Good afternoon, Algebra 1. Today what we are going to do is we are going to be talking about solving quadratics. So when we are solving quadratics, really what we're doing is we are looking for the roots of a function. We're looking for the zeros. We're looking for where it crosses the x-intercept. So for example, if you had this little chart right here, we talked about what is a quadratic and what does it look like. And a quadratic forms a U-shape, or it could also be upside down as well. And what I'm looking for is I'm looking for these roots right here. I want to figure out what those numbers are. And so we talked about there are several ways that you can do this based on the format that you're given. May sometimes ask you to construct it based off of the graph or say what the roots are, and of course those would be the points at which it crosses the x-axis. The other ways that we can do it is if I gave you the formula. So, or not really the formula, if I gave you an equation. And so for the equations down here, we have a couple different steps to solve quadratics. So our first step is going to be, we want to make sure that everything is on one side. So we want to bring all of my numbers, all my variables, over from one side to another. Basically, I want my equation to equal 0. The second thing that I'm going to do, step number 2, is I'm going to factor. Now, I won't always need to factor, and I also won't always need to do step 1. If you look at over here to the left-hand side, we don't have to do either of those. But in the event that you do need to, factor, you can either do that using foci or using any of the methods that we've talked about previously. For number 3, the third step that we're going to do, once you have factored everything, then you are going to individually take each term and set it equal to 0. So we're going to set each term, each part, if you will, equal to 0. And then what we're going to do is we're going to solve for the variables. Because again, our goal is to figure out what are the x-intercepts, what are the x values. So when I'm going to do this, I'm going to set, for this one, the first two steps I've already done, so I'm going to set these two equal to 0. So I have negative 2 is equal to 0, x minus 2 is equal to 0, x plus 9 is equal to 0. Alright, so from here, what I'm going to do is I'm going to solve. Now if I look at this first one, negative 2 is equal to 0, I really can't solve that. So for this one, really that negative 2 represents the GCF, and for my GCF, when I pull that negative 2 out, you do not have to worry about really that number unless it has a variable attached to it. If it is just a number, you can leave it. You can basically kind of cross it out here because you don't have to deal with it. Now if it had a variable attached to it, if it was an x instead of a 2, it would end up being x is equal to 0, meaning you have a root of x is equal to 0. We're not going to talk about that, and you probably will not see that until a little bit later in your math career. So to do the remaining parts, you're going to solve the following. So in order to solve x minus 2 is equal to 0, I'm going to add a 2 to both sides, add a 2, x is equal to 2. To solve the other one, I'm going to subtract a 9 from both sides, so I'm going to get x is equal to negative 9. So now my roots, my zeros, my solutions are x is equal to 2, x is equal to negative 9. I'm going to have two different answers. Now for those of us who remember from the previous class when we talked about doing this graphically, we said there's a relationship between the factors and the roots. We said that the factors look like opposites of the root, right? Up here we have x minus 2, but our root is x equals 2. X plus 9, x equals negative 9. Okay, so we do have the relationship between the two. They are not the same number. They are the opposite of that number. So, as we're moving forward, we're going to go through and do each of our steps. So we're going to look and see if we can first bring everything over to one side, basically have it being set equal to 0. So if I look at number 1, this one's already done. Step 1 I can check off. I already did that. Step number 2 is going to be to factor. So when we factor, we can use foci. For this one, because we have no number in front of the x squared, I'm just going to, we talked about foci in other words. We said numbers that multiply to a certain number and add to another number. So numbers that multiply to -8 that add to 2. So we're going to list out all the possible numbers that multiply to -8. So I could have a -8 and a 1. I could have a -4 and a 2. I could have a 4 and a -2. And then I could have 8 and -1. And now I'm going to say when I add each of these pairs together, which one is going to get me a +2? And the only one that does is 4 and -2. So when I go to rewrite this, when I write my equation, I'm going to say x plus 4 times x minus 2. That is the fully factored out form of number 1. However, when we're solving, we have to keep this equals 0. And the reason why we're doing that is because we want to set each of these terms individually equal to 0 as we transition on to step number 3. So I'm going to get x plus 4 is equal to 0, and then we're going to have x minus 2 is equal to 0. Don't know why I wrote these in parentheses here, but we don't really need them. Let's rewrite that. So then what I'm going to do is I'm going to solve for each of these individually. So I'm going to subtract at 4 from both sides, get x is equal to -4, x is equal to a +2 when I add a 2 to both sides. So here are my answers, my roots, my zeros, my solutions. Alright, so that was pretty straightforward. Now, as we look at number 2, we got to do a couple additional steps. So the first step that we have to do that's different from before is we have to subtract this 10 from both sides. So once I subtract that 10 from both sides, my new equation becomes 14a squared plus 4a minus 10 is equal to 0. Notice I can't combine that 10 with anything because the 10 doesn't have any like terms on the other side, so I just leave it as a minus 10. Now what I'm going to do, and whenever we factor, we always have to first look for what we call a GCF, the greatest common factor. The greatest number, the largest number that goes into everything, and the smallest variable that goes into everything. So if I look, I notice the largest number that's going to go into everything is going to be 2, and there is no smallest variable that goes in because not everything present has a variable. So I'm going to factor out a GCF. In other words, I'm going to take each term and divide it by that GCF. So I'm going to be left with 7a squared plus 2a minus 5 is equal to 0. Once I have it factored out, my GCF, then I will go and do very similarly to what we did over here. I'm going to do foci. So this time I'm using foci because I have my a term, the number that is directly in front of a, the first term, is greater than 1. So what I'm going to do is I'm going to do the factors of whose sum is. So I'm going to look for the factors of the first term times the last term. So 7 times -5, which will be -35, whose sum is that other middle term of 2. So what I'm looking for and what I'm going to do is I'm going to list out all the numbers who multiply to -35. So I have -35 and 1, I have -7 and 5, I have the opposite, 35 and -1, 7 and -5. And so once I have this, what I'm going to do is I'm going to say if I added which pair together is going to get me a +2. The one that does that is 7 and -5. So the last part of foci, because I multiplied by this 7 to begin with, I have to divide out by that 7. Now what we usually wrote is we wrote the variable up top as well, just to let us know that we were dealing with the variables. Coefficients were going to be up top, and then whatever my factors, these guys, coefficients are going to be on the bottom. And so now what I do is I want to simplify, so I want to see if my numbers can cancel, if I thought about them as in terms of fractions. I notice that the first two can, so they're both going to become a 1, and my right hand side cannot. And so now what I'm going to do is I'm going to rewrite these factors. So I have my a plus 1 times 7a minus 5, and I'm going to leave that 2 that I factored out, my GCF, on the outside and set it equal to 0. So now what I've done is I've taken this original problem in number 2, I've factored it completely, and my last step that I have to do is I have to solve for each of the a's. So I'm going to do a plus 1 is equal to 0 and solve. So subtract 1, I get a is equal to negative 1. And then my other one is 7a minus 5 is equal to 0. So when I go to solve this one, I'll add a 5 to both sides. I get 7a is equal to 5. Divide both sides by a 7. So a is going to equal 5/7. So my answers are, my roots, my zeros, my solutions are going to be a is equal to negative 1 and a is equal to 5/7. So we talked about this in class a little bit. When you graph these, you can always use the graphing calculator to check your answers. When you graph these, this answer is going to be a decimal. So when we're going on quizzes and tests, and when you guys see this in the future, the expectation is that you have them in terms of fractions. So that way we can see what the roots are and how you did it by hand. Alright, so as we move down to number 3, my rule for doing foci, just I guess as a reminder, is that that number in front of my coefficient has to be larger than 1. So as I'm going to take that thought and keep that kind of brewing in my head as I go to number 3. Because for number 3, if I want to use foci, and again, the first step is always to make sure everything is on one side, and then from there we'll factor things out. But if I notice, if I moved this negative 2x, if I subtracted 2x squared from both sides, I would now have negative 2x squared plus 3x plus 35. And when I go to do this, I'm not going to end up with, first of all, my a value is smaller than 1, so I can't use the foci method. So with that in mind, we probably should not subtract the 2x squared first. We would have to kind of sit around and come up with what our factors might look like instead of using the nice foci method. So instead, what I'm going to do is I'm going to subtract a 3x and then subtract the 35 from both sides. So my new equation is going to look like I have 2x squared minus 3x minus 35 is equal to 0. And so when I'm thinking about factoring, my next step is always look for the GCF, or my first step of factoring is always to look for the GCF. If you don't have a GCF, like we happen to for this one, we don't happen to have a GCF, then what you're going to do is you're just going to move on with the problem. So we're going to go ahead and move on to foci. So as I'm doing foci, I want to look for factors of 2 times negative 35, so negative 70, whose sum is negative 3. So I'm going to list out, factors of negative 70, and again, I'm not going to list out all of them. I'm just going to list out the 2 that work, which I know are going to be negative 10 and 7. So I'll make my t-chart. My t-chart is going to have a 2 on top. I'll write a little x, so we know that it's the coefficient of x that we are looking for on top. And now what I'm going to do is write my factors on bottom and simplify. So I know that the left-hand side is going to simplify to a 1 and a negative 5, and the right-hand side is going to remain the same. So my new factors are going to look like x minus 5 times 2x plus 7, and that's all going to equal 0. So now from here, I'm going to set each of these individually equal to 0 and come up with an answer. So x minus 5 is equal to 0. If I add a 5 to both sides, I'm going to end up with x is equal to a positive 5. That is one of my roots. The other one, when I subtract a 7, I'm going to get 2x is equal to negative 7. Divide both sides by 2, not a z. And x is going to equal negative 7 halves. So that is my answer for number 3. And number 4 is going to be a little bit different as well. So it is already solved. Step 1 is already completed for number 4. What I have to do is I have to factor out my GCF. What is my greatest common factor? I only notice that it ends up being 2. So I put a 2 on the outside. I have x squared minus 16 is equal to 0. Now immediately when we look at this, we might say, whoa, we're done. Don't got to worry about anything. But we got to remember difference of squares. So difference of squares says, and we talked about that a little bit, we said, alright, I know that x squared is a perfect square, right? It breaks down into x and x. I know that 16 is a perfect square. It's going to break down into 4 and 4. So, what we said, the little special rule or the special little thing that we did is I know I'm going to have an x and a 4, I know I'm going to have an x and a 4. But what I want is I want that middle term to cancel out because there's nothing in between. So we said one's going to have a plus and one's going to have a minus. I'm going to drop my 2 down as well because that was my GCF, set it equal to 0 to keep it as an equation form, and now I've fully factored it. And so my last step, once I have everything factored out, is I'm going to set them both individually equal to 0. So x is going to equal -4, and x is going to equal a +4. So my two roots are -4 and +4. Alright, so the last thing, this is kind of reverse engineering everything. So I'm starting off, for all the other ones I was starting off with the factors, or I was factoring. For this one it's saying we are giving you the roots, go backwards. So right now what I'm saying is if you have 4 and you have 5, I have x is equal to 4, x is equal to -5. Alright, so if I want to go backwards, kind of if we're looking up here we can see the blue a little bit still. If I wanted to go backwards from this, right, I would subtract a 4, get x minus 4 is equal to 0. For this one I'd add a 5 and add a 5, x plus 5 is equal to 0. And then let's think about what we did next, right? After we have them both equal to 0, we wrote them in parentheses. Okay, so we can do that. We can do x minus 4 times x plus 5 is both equal to 0, right? Alright, so that looks good, right? We got our factors. Everything looks great so far. So it says determine what the factors would be. I found the factors, awesome. Then determine what the polynomial would be. So now that I have the factors, what I wanted to do is I wanted to bring it back to a polynomial. Basically, I wanted to make it look like this guy right here. Well, how could I go from this step down here back upwards to that first step? If you remember from a little bit of some time ago, we did something called double distributing. So what I did is I took this first x term and I multiplied it by x, and I multiplied it by 5, and then I took the -4 and multiplied it by those two terms, and I solved. So when I multiplied the x by x, I got an x squared. X times 5 is going to be 5x. Then when I go to multiply, I'm going to have a -4x and a -20. And we're going to leave the equals 0. Alright, so now from here we notice I've got these two middle terms are similar. I can simplify them. So what I'm going to have is I'm going to have x squared plus x minus 20 is equal to 0. Now I've come up with a polynomial whose roots are these above, or whose roots are these above, whose factors are these. So I have my question answered. I'm going to do the same thing for number 7. So if we want to follow that same process, I know that x is equal to -1/2. I know that x is equal to a 3. Now when we go to write these as factors, if I were to add a 1/2 to both sides, I have x plus 1/2 is equal to 0. I have x minus 3 is equal to 0. The one thing that's a little different is we have a fraction right here. Now, of all the stuff that we have before, even the root, if we look at this one right here, this blue above, the root ends up being a fraction, right? Just like this one. However, if we looked at what the factor was, it was 2x plus 7. So when we're dealing with factors, we never have fractions as our other number. So in order to get rid of this fraction, we're going to multiply by the fraction's reciprocal. We're going to multiply by a 2. So if I multiply everything by 2, what I'm going to end up with is I'm going to end up with 2x plus 1 is equal to 0. And what I can do is I can actually go ahead and, if I wanted to, verify to make sure that I'm still going to get the same root from this equation as I did from this one above. I could subtract 1 and double check and verify that I still get x is equal to -1. But because I now have this, I can move forward. That is a factor. That is a possible factor. We are not allowed to have any fractions as one of our numbers for the factors. They have to be integers. Alright, so from here, I still had x minus 3 is equal to 0. So if I were to write these in parentheses as my factors, I would have 2x plus 1 times x minus 3 is equal to 0. Alright, so now again I'm going to double distribute just like I did earlier. Multiply the 2x by everything. Multiply the 1 by everything. And what I'm going to be left with, I'm just going to keep it in nice purple. I have 2x squared minus 6x plus x minus 3 is equal to 0. So I have 2x squared minus 5x minus 3 is equal to 0. And that is my answer. Alright, so I hope that this video has helped you understand things a little bit better. That is all that I have for you. I hope that you enjoy the rest of your day.